different aspects of their health. Of course, the Fitbit, which is an accelerometer that can measure your activity. The Zeo, which is a device that straps to your forehead and measures the quality of your sleep and how much sleep you're getting each night. To Body Media, which is probably the best validated device that is up there, that has been shown through scientific studies to be accurate, with skin galvanometry and other sensors to measure your metabolic rate as well as your activity. To something as science fiction-y as the Proteus smart pill, which is a real device. It's going on for sale in the UK. And what they do is they attach a microchip to your pill. So as you swallow your pill, it's detecting that you're taking your medications. And sending all of these devices are sending that data to the cloud, where it can be accessed by people, analyzed, visualized. So very interesting developments in self-tracking in terms of just of the devices themselves. And even in the last few weeks, there's 2 more devices I find very interesting. Let's show them to you. Here is the Beam Brush toothbrush. So I just talked to Alex Frohmeyer, who's one of the co-founders of this company. And it's a toothbrush that it measures when you put it in their mouth, and it measures how hard you're brushing, and it tracks all that information and gives you feedback. And they're even imagining a model where your dentist can prescribe to you a brushing habit and see how you're brushing. Or maybe there's a specific tooth that you need to focus on, and the brush can give you feedback. But right now, it's a tracking, how you're brushing, your brushing habits, and let's continue. And it's sending that information to the cloud. And of course, Lumobac, many of you might be familiar. They just did a Kickstarter campaign. This is a device you strap onto your waist, and it measures your posture. And then if you're slouching during the day, it gives you a little vibration, a little auditory feedback to tell you to straighten up and improve your posture. So lots of interesting devices. Let's continue. So I'm going to ask you a question, because this is a question that I have. Is this entertainment or is this science? And I think that's an important question, because a lot of these devices are being made for and purchased by consumers. They're not being made for and purchased by researchers or physicians or healthcare providers. So is this entertainment or is this science? So I'm going to leave self-tracking by giving you one final example of self-tracking where I think we can maybe say it's science. So let's talk about this one. Next slide. So this is one of my colleagues at Stanford. He's the chair of genetics, Michael Schneider. And only 3 or 4 months ago, he published this paper, a very interesting paper, because in this paper, he describes self-tracking that he did on himself. But he didn't use any devices that he clamped to his body. He did molecular self-tracking. So let's talk about this experiment. Next slide. So in this study, he did genome sequencing, of his own DNA. And then he did proteomics, and he did metabolomics, and he looked at many different factors that he could isolate from his blood. And he tracked those molecular measurements over time, over the course of 14 months. So let me tell you, let's talk a little bit about this experiment and the insights that he found. So let's continue. So an example of self-tracking, published in Cell just this March. So he did the genome screening of himself, and he found that he was at significantly increased risk for type 2 diabetes. Even though he didn't have any of the risk factors, he had a BMI of 23, he was a non-smoker, very healthy person, no risk factors for type 2 diabetes. But his genes, his genetic analysis said risk factor. So they designed part of this self-tracking to be looking at blood glucose levels, hemoglobin A1C, and blood glucose levels. Continue. And he tracked those over time. And so here, this is the result of his self-tracking study. So he started at day 0. They're tracking his blood glucose. On day 289, he gets a cold. A really bad cold. He's in bed for a couple days. After the cold, his blood sugars spike. And so he begins to see, before he has any outward signs, that he has diabetes. Before he had the polydipsia, before he had to go to the bathroom, before he had any signs, the blurry vision, through self-tracking, he was able to see that he was becoming diabetic. So he went to his doctor. He instituted lifestyle changes. That's the black bar. And you saw he got that under control very quickly. So I think this is a remarkable study because it shows us the potential self-tracking might have for our patients. If we could identify risk factors, if we could track for those markers, biomarkers of disease, early detection, early treatment to prevent those complications that develop later. That's what I think is remarkable about this study of self-tracking. So I'm not going to dismiss self-tracking as something as entertainment, because I do think that there is valid science that can be developed. But I do think that there's still a lot of work to be done on the different ways we use it, different technologies. But just imagine just the richness of this data for this one patient that exists, that can be in the cloud. These are very interesting things, interesting times. And I think self-tracking is another one of these trends that's leading me to my next idea. Go ahead. Okay, let me talk a little bit more about the last slide here. So we talked, is it a fad? I'm trying to say I don't think it's a fad. I think that there's promise for it. But we as physicians, healthcare providers, we need to understand this so we can contribute our ideas so that we can make this scientifically and medically valid. We need to show that self-tracking can improve health outcomes. We need to find ways that we can take that self-tracking data and incorporate it into the healthcare experience. So if I'm a healthcare provider, how am I going to access your self-tracking data that's in the cloud? How am I going to integrate it with your personal health record or your electronic medical record? What are the open mHealth standards that we're developing that will enable those connections? And then this is then now leading up to my next idea, which is, but what if we could do that? What if we could integrate self-tracking with someone's genomic data, with someone's electronic health record? Because all those technologies exist now. And if that was all up in the cloud and we could look at all that data in one coherent way, so what's the potential of that? That's my next and last topic, which is big data. Let's talk about big data. Okay. So this is another one of my colleagues at Stanford. His name is Atul Butt. He's the chief of systems medicine. He works in the Department of Biomedical Informatics. And he looks at big data. Go ahead. And what is big data? So big data is kind of this concept of lots of data, both structured and unstructured, that exists in public databases, but which, for whatever reason, as scientists, as physicians, we're not really looking at deeply to see if we can gain more insights. But what if we did? What if we were able to look at public databases and gain new insights? That was one of the questions that he had last year when he published a very interesting paper that we're going to talk about. So here he looked at two publicly available databases. One was the Gene Expression Omnibus, which basically looks at the effects of different diseases on gene expression. So they can see which genes are upregulated, which genes are downregulated when someone has a disease. The other database, publicly available, that they looked at was the Broad Institute's connectivity map database, where they basically have a whole database of gene expression changes that happen in cultured human cells. So they take petri dishes of human cells, they add a drug to those cells, and they see what happens to the gene expression, which genes are increased and upregulated, which ones are downregulated when these cells get a drug. So let's look at some of what they found in this study. Very interesting study. In the United States, we have a website called Match.com. Do you have something similar here? It helps match people together who want to date each other. Okay? So they wanted to do that. Let's create a Match.com between these drugs in the connectivity map, right, and diseases in the Omnibus database. And here's the hypothesis. They said, okay, if we know that a disease will upregulate certain genes and downregulate others, then maybe we can see if we can find drugs that do the opposite to the genes. And if we do that, maybe we can find new uses for existing drugs. Does this make sense? Yes? No? Okay. So they used informatics algorithms to score the relationship between various drugs in the database and various diseases, to find ones where that had the perfect opposition in terms of gene expressions patterns. And really interesting results. Let's continue. Let's see what they found. So here's the idea. You can see they have diseases over here. They have a certain gene expression signature for the disease. Then they have the drug database, certain expression profile. Then they put that into an algorithm to try to find the drugs that have the most opposite effect to the disease. Let's continue. So here are some interesting insights they found. Cimetidine, a drug that's used to treat peptic ulcers, through their computer algorithms analyzing big data, was found to be possibly therapeutic for treating adenocarcinoma. So this is completely unrelated. Peptic ulcer, adenocarcinoma, very completely different. They went one step further. Let's do an experiment. So let's take, in a petri dish, let's take adenocarcinoma cells, and let's add cimetidine in there and see what happens. And they were able to, through in vitro studies, confirm that cimetidine did, in fact, diminish cell proliferation and increase cell death with adenocarcinoma. So they took something, an in silico experiment, and showed in real life it works. So this is some of the promise that we have with big data. Next example. Was that a fluke? Was that a one-time coincidence? They did it again. They showed that the anti-seizure medication topiramate was possibly therapeutic for inflammatory bowel disease. They did the same in vitro experiment. They took rodent models of Crohn's disease and showed that if you put topiramate in there, that it actually reduces the symptoms of the disease and it helped heal inflammatory tissue injury. So again, in silico experiments on big data leading to real-world insights and discoveries that we didn't have before. So that's really exciting to me. It's an example of the promise that big data might have. Go ahead. So I'm going to end just by putting it all together for you. Let's put it all together. So 2012 was really exciting for me because that's the year that I learned about it in late 2011, but the C3N project at the Cincinnati Children's Hospital, which is a remarkable study that is really putting together all these ideas that I've just talked about for one purpose, which is to improve the treatment of chronic disease. So Michael Seed and his co-PI there, they wrote an 8-page grant application to the National Institutes of Health under this transformative R01, which is high-risk, high-reward projects. So for each page, they got $1 million because it was an $8 million grant that they got to basically. When we wrote an article about C3N on our Medicine X website, Susanna Fox logged in and wrote a comment, and she said, because she is also really respects what they're doing and characterized them as having the audacious goal of trying to unite building social capital, peer mentoring, with big data and sharing data, and creating a network that incorporates all of these different touch points I've just mentioned to improve health. So let's talk about that very briefly. So this is kind of their roadmap, okay? They're engaging patients by building social capital through social media, through peer-to-peer healthcare, by allowing patients to produce their own practice knowledge and publish it through their networks, so that patients with inflammatory bowel disease or Crohn's disease can go onto the networks and get advice from each other. They created mobile apps where these patients can track their symptoms and health and upload them to their network, where researchers and physicians and patients can have access to that data. They are integrating their efforts into Facebook and other social media. And they're doing these really cool N of 1 experiments. Let me talk very briefly about N of 1 experiments. So here's the concept. This is a real patient, Emily Blosser. She began having Crohn's symptoms when she was 3 days from her 10th birthday. Caused her to have to really limit her school activities, what she was doing, her childhood. And she went in and became part of the C3N project, part of this chronic care collaboration network. And they did an N of 1 experiment. And this is an experiment just for Emily. So what they did is the patient, Emily, met with a researcher and a physician, and they came up with a question. Let's come up with a question just for Emily that we can test. Maybe in this case is, do your symptoms increase when you eat certain foods? That team then works to design an experiment to help answer Emily's question. Then they go and they conduct that experiment. How do they do that? By using mobile apps, by using self-tracking, so that as she's maybe eliminating bananas from her diet, I'm just making things up, I don't know really what they did, she can track her symptoms and see did they change when she's doing this experiment that she designed in collaboration with the researchers and physicians. Then they can meet as a team with Emily, where the doctor is meeting with Emily to go over her data together. And they talk about the result of the experiment, what they learned, and if they can make changes in her diet that are going to improve her disease management. And actually, she went through the C3N program, and her management is much improved, and she's actually back in school and doing well. And I'm going to end on my last slide here. Go ahead, the last slide. So here's my last slide. So this is my vision for one approach to looking at how we can use all these emerging technologies in medicine today. We have these tools, but we're just not doing it. So in my hypothetical world, Emily might be genotyped or have a gene analysis at birth, identify what her risk factors are for developing diseases, much in the same way Michael Schneider did when he did molecular sequencing and molecular self-tracking. So we identify what people's disease risks are early. Then we use self-tracking to, whether that's for self-tracking of symptoms or biomarkers, to have early detection of these diseases so we can find out when somebody's starting to present with the disease and treat them early. When they are treated, the healthcare team looks to see, is this patient someone who would be receptive for building online social capital? And we know the websites, and we know the social networks, and we know the resources we can recommend to help them build social capital as a patient and their families to help them better manage their diseases. And for certain things, especially Crohn's that you see, we think about doing these N of 1 experiments, right? N of 1 experiments for individual people to see if we make changes, how we can help them manage their disease. And of course, the really interesting thing is when we have these millions of data points and that they're all being shared in the cloud and we have big data, can we then start to use these interesting algorithms, things that Atul Boot and other people are doing, to get new insights about how to treat diseases we may never have thought of before? And that, to me, is the idea, is to integrate thoughtfully all these different aspects of emerging technology. And so that's the message I want to leave with you today. As you're here and you're learning about all these new ways to communicate, these new technologies, think, how can we create a bigger picture where we can work together to improve health? So thank you very much.